Hello everyone, and welcome to 8th grade Math Module 1, Integer Exponents and Scientific Notation. Today we're looking at Lesson 2, Multiplication and Division. Hello everyone, and welcome to 8th grade Math Module 1, Integer Exponents and Scientific Notation. In this video, we're looking at Lesson 2, Multiplication and Division of Numbers in Exponential Form. Our learning goal is to make sure we can use the product rule of exponents to simplify exponential expressions. This will help us to master Standard 7 EEA1. Know and apply the properties of integer exponents to generate equivalent numerical expressions. So we talked last time about when we multiply repeatedly, we can express that multiplication as an exponent. So for example, if I had 7 multiplied together, so that there were 4 7s being multiplied together, that would be the same as 7 to the 4th power. And if we multiply together 7 to the 4th power by 7 to the 2nd power, it would look like this in expanded form. We would have 4 7s multiplied together times 2 7s being multiplied together, which is the same as just having all 6 of those 7s being multiplied together. And when we have 6 7s multiplied together, that's just 7 to the 6th power. So that's part of what we're looking at here is when we multiply together numbers that have the same base, all that we really need to do is add together their exponents because that tells us all together how many of that number is being multiplied together. And this only works when we have the same base, like these all had the base of 7. So for example, if I had 4 to the 2nd power times 4 to the 5th power, then that would be the same as, 4 to the 2nd power has 2 4s, and 4 to the 5th power is 5, so altogether that would be 7 4s. And then if we wanted to find the value of 4 to the 7th power, then we could just go into our calculator, use 4, put in whatever our button for the exponent looks like. We talked last time about how in some calculators it might be an x2 and then like a little y or something like that, or it could be an up arrow looking caret. But when we put that in, we get 16,384. So it can be a lot easier sometimes to write things in our exponential form. This shortcut of taking our numbers that have the same base that are being multiplied together and just adding their exponents is actually the product rule or the product law, and it's the first law of exponents that we will be learning in this module. And so it makes it really easy to simplify expressions that have exponents. So you can actually try to apply this law of just, again, adding together the exponents of numbers with the same base that are being multiplied together. And you can try that with these 4 problems right here, and then unpause the video when you're ready to go over it. So in exercise 1, we have 2 numbers with the same base of 14. And since they're being multiplied together, we are just going to add their exponents to get 14 to the 31st power. In exercise 5, right next to it, we actually have the same exponents with a base of a. And a could be any number, so it doesn't actually matter as long as we keep that base of a there, because the base is the same. We do the same thing with our exponents, we end up with a to the 31st power. In example 4, we have negative 3 to the 9th power times negative 3 to the 5th power. Keep note of the fact that the parentheses are around that negative 3 with the negative inside. That lets us know the negative is part of the base and doesn't get added on after. So we just still add up those exponents and we get negative 3 in parentheses to the 14th power. Now, if instead of having an x in our base, like we had an example, or a variable in our base, like in example 5, if we have it in our exponent, what changes? Well, nothing. So if we have x being a positive integer in negative 3 to the 9th power times negative 3 to the x power, and we get that negative 3 is to the 14th power, we can find x using what we know about this law. So since our bases are all the same here, what we would end up doing is negative 3 to the power of whatever 9 plus x is. And they already told us that's going to be 14, so I just need to figure out, well, what number could I have added to 9 to get 14? That's 5. So that second term there, that negative 3 to the x power, the x would be 5 in order to make this equation true. Now what happens if we start putting more than 2 terms into our multiplication problems? You can pause the video here and try to solve these ones and hit play when you're ready to go over them. In exercise 9, all of these terms have the same base, so even though there's more than 2, we still do the same procedure of keeping our base the same and adding together all of these exponents. So 4 plus 6 plus 13 is going to get me an exponent of 23 with my base of 9. Same thing in exercise 10, only for this one we have base of 2, so we're going to add together the 3, the 5, the 7, and the 9 to get 2 to the power of 24. Now, in exercise 11, it gets a little trickier because we actually have 2 different bases. And just like when we did combining like terms in 7th grade algebra, I like to highlight in different colors my terms that, in this case, have the same base instead of the same exponent. So I made all my 6s yellows and all my 4s red, and that's again for the base, not the exponent. So now I can add together the exponents of terms that have the same base. So I could do the 6 to the 5th plus 14th power times the 4 to the 9 plus 3 power. So I end up with 6 to the 19th power and 4 to the 12th power when I add together the exponents. Again, you can only add the exponents that have the same base that are being multiplied together. Now in exercise 14, we have 2 to the 4th power times 8 to the 2nd power, and they don't have any common base there, so we can't really simplify that unless we can write 8 to the 2nd power with a base of 2, and that ties into the factoring we did at the end of our last video lesson. So I can actually, 8 to the 2nd power, 8 times 8 is 64, and 2 to the 6th power gets me 64. That also equals 64. So if I rewrite it that way, then I can simplify this out to find that 2 to the 4th power times 2 to the 6th power is 2 to the 10th power. And this is sort of at the more advanced edge of what we'd be looking at doing with this product rule. So just to check here, our friend Mr. Magnata says you can use the product rule and simplify 7 to the 2nd power times 2 to the 4th power and get 14 to the 6th power. Is he correct? Why or why not? Well, that'd be really great if we could just multiply all the numbers together, but our product rule only works when the bases are the same, and 7 and 2 are our bases here. Those are not the same. So remember, we have to add just the exponents and keep the bases the same. Now, if there was a way to write 7 to the 2nd power, 49, with a base of 2, then we could probably do that with the 2, but there isn't, unfortunately, a way to write 49 with a base of 2. If we did its factoring, we would just end up with 7 to the 2nd power. So that's not going to work. Now, the product rule of exponents says when bases are the same, you add the exponents. So what do you think is going to happen when we move into division then? Well, let's think about how multiplication and division are related. They're opposites. And the thing we do with multiplication is add, and the opposite of adding is subtracting. So it seems to make sense that when we are dividing numbers with the same bases, then we would subtract their exponents. And this is, in fact, our quotient rule or our quotient law of exponents, the second one that we are learning. Now, the important thing to keep in mind with this rule is that you have to subtract in order. So you have to take the exponent from your numerator and subtract it from the exponent in the denominator. And I color-coded that in the box at the top that goes over this rule and how it works. So let's see if we can apply that to some problems here. You can pause the video and try to apply your quotient rule to these 4 problems and hit pause when you're ready to go. So just as before, I'm going to start by writing my base for each of these exponent pairs, and then since we have division, I'm going to subtract. I'm going to do it in order. So for 7 to the 9th power divided by 7 to the 6th power, I'm going to keep my base of 7 and do 9 minus 6 to get 7 to the 3rd power. With 8 to the 5th power, 8 fifths, I'm going to keep that as my base and then take the 9th power minus the 2nd power to get 8 fifths to the 7th. My negative 5, just like my fraction of 8 fifths, is going to be in parentheses. I'm going to do 16 minus 7 to get it to the 9th power. And then 5 minus 4 is 1. So I'd end up here in exercise 24 with 13 to the first power, and a number to the first power is just itself. So actually the simplest way to write that is just 13. So now let's try to make this a little more advanced here and try to use our quotient rule for these. In exercise 27, 2 to the 7th power and 4 to the 2nd power do not share a base. However, if we use what we know about factoring, 4 times 4 is 16, and if I factor 16, that's actually 2 to the 4th power. So I can do 2 to the 7th power divided by 2 to the 4th power, and I find that that equals 2 to the 3rd power. 7 minus 4 is 3. And then for exercise 29, again, we can only do this with numbers with the same base. But I do have in here, I can even just kind of split this up in my head into two problems here. I can do 3 to the 5th over 3 to the 2nd times 2 to the 8th. Make that look less like 28 and more like 2 to the 8th over 2 to the 3rd. I can split it up like that in my head, and then I can do my factoring from there. So if I do that, I just do the 5 minus 2 to go with my base of 3, and then the 8 minus the 3 to go with my base of 2, and I end up with 3 to the 3rd power, 5 minus 2, and 2 to the 5th power, 8 minus 3. What does this video make you wonder about using the product rule or the quotient rule to simplify exponential expressions? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learn from your failures, then you succeeded.